So yeah, I created a struct here on YouTube. Let's see, Cicerate viewport. Am I supposed to do like that to get rid of the warnings? Uh, let's see. Yeah, okay. I should initialize it, but yeah. I'll mess around with that later. But yeah, as I've mentioned here on Twitch, I haven't even included the vector library yet, which is amazing to me because usually you include it like so early during any programming project, but I guess we're working with custom data structures and something that is a little bit more low level. So type def std vector. Using namespace std. Let's see. Does that help? It does, but yeah, we'll see. I actually sometimes prefer not to enable it, even though it does end up being a lot more typing. Vertex list. Let's see. Vertex temp vertex. So right now we are looking at the origin. Let's see. Let's expand this. So we're looking at, if we redefine stuff, x red, y, and c. There we go. If this is our planes, we'll have our coordinate system as follows. Oops. There we go. There we go. So our camera is looking at its, if I can draw something fairly precisely out along the z-axis, it's here and looking at the origin here. So if we place a vertex, oops, if we place a, this time no fill. That's what we're looking at. If we place a vertex, let's say we place it somewhere like here and here and here. So this could be minus. Yeah, let's just do it. So the first one would be -1 for the x. Um, uh, 1 for the y. And AC of, let's say, 1. Actually, we shove it all along the c-axis. Then we and place that. Remove it. There we go. Our first vertex. Then we will create our second one, which will have a y position of -1. It will have an x position of 0 and AC of the same value as before, since we are not manipulating the C. Okay. Last one, the X position, the Y position, and the C position. There we go. Nah, it should be initialized as 0. Yeah, maybe we don't move. Maybe we just copy create. Yeah. We copy this in. And let's just test that everything is, whoops, not during release mode. Let's do debugging instead. So let's see, we do some vertex lists. Let's see. So yeah, they are different. We have 3 vertices. Let's say that we want to create a let's say that we want to create a vertex buffer and we want to initialize it on our device. We want to create it with the size of 3 vertices. We want to create it on a default heap, and back in the, I think it's the 3D resource state common, right? I'm able to upload. Am I able to write to that? Let's see. And our linear buffer queue the upload to our vertex buffer. Reference. We don't want an offset. We would like to upload our vertex list data that returns a vertex pointer, and we want a size of vertex times 3, and let's try to upload that. Do we get any errors? Let's see. Not that. Let's see. Let's see if not that one. Let's see if we do get any results. We have a buffer. The first 4 bytes. Index address. Let's see. Float 3. Float. Whoops. Float. Float. So float, 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 float. So there we go. Is that our actual data? Let's see. The first one is supposed to be -111. The next one is going to be, yeah, the last byte is padding, so there we go. Yeah, the last byte is padding. Okay, so we do get. We could also do something like a float 3 and then like this. Yeah, pretty neat. Pretty neat. All right. Then we would like to create a uh, vertex buffer view. So that we can bind it to our pipeline. Let's see. Let's create a vertex buffer view. Let's see. Buffer location. Let's do the vertex buffer. Get resource. Get GPU virtual address. So we specify where the buffer is located. Stride in bytes is equal to the size of the vertex, and the size in bytes is equal to the size of the vertices times 3. Yeah. And we would actually like to store that. So let's see. Let's store it as a pointer. Vertex buffer view. Dereferenced. Copy in the information. Or rather, let's just do like that. Usually you'd end up doing this inside some wrapper function, wrapper objects, but not for now. We do it manually. Let's check. Let's check. Then during our render pass, we do command line man. Get D12. What? Not like that. Graphics list. Man, I can't spell. Set vertex buffers. Start slope. Number of views and our vertex buffer view. Let's see. Uh, uh, read access violation. All right. Huh. Oh yeah, of course. It's a null pointer. Mm, mm, maybe I'm not supposed to store it as a pointer. Maybe I should store it as an actual description. Yeah, I think that would be better. Because it's not stored anywhere. It's just a pointer. Let's see if we change that for now. And we pass that by reference. There we go. Mm, let's see. What about our draw call? Let's see. Let's set up our draw method. Let's draw 3, 1 instance. Let's see. Usually you can look up um, inside the event list whether let's see that one. Yeah, so as you can see, it actually draws a triangle somewhere in our system. Uh, so it definitely knows that our let's see. Uh, yeah. So far we got a triangle. inside our geometry, but we're not shading anything. So this means that we draw the triangle, but we do not translate it in any way. Let's see. So we take an input. We would like to calculate an output. Let's see. Yeah. Yeah. So the world position is going to be a multiplication of uh, let's see, float 4x4 world ident. We define that as 1, 0, 0, 0, and 0, 1, 0, 0, and 0. You guessed it, 0 and 1 and 0, and the last one. There we go. So we do the a float 4 version of our input dot position and an extra float, and we do our world ident, and afterwards we multiply the um, uh, world position with our pass data constant buffer view projection. And let's see. Implicit truncation. Let's see. Uh, yeah. Now I know why. Let's do this in a separate step. Uh, like that, and we do x, y, z, and we do that one instead. There we go. Uh, this should just let's see, let's move the camera a bit further away. Let's see, let's see, let's see, let's see. Am I supposed to do these things? Let's see. Uh, uh, let's see our vertex shader. So yeah, we do get something transferred to the. Oh hi. Oh sorry, I hadn't seen your messages. Uh, I haven't heard about DirectX12, but the Agility SDK is out. But yeah, I've been in this situation before in terms of having to figure out what is missing for it to actually draw the triangle. I just can't remember what it is I'm missing. Let's see, I'll just launch Inside. Let's see. Okay, you're still here. Hopefully you don't have me muted. Just gonna type in the chat to make sure. Let's see. Let's. Okay, cool. So our event list here. As before, we do draw the geometry, I think. Yeah, we do. What is it? I forgot. Is it the... No, it's not the depth stencil, is it? I know I need a... I set up the rasterizing, or rather pixel shader, to put out a color of white. So I don't think so, but in case, yeah, we can just check. I'll just upload the shaders. Whoops. Let's try to replace them and reboot the application. The last time I did this, I had the exact same problem, and I eventually I solved it, but I'm probably too tired to remember. Let's see. It doesn't draw anything to the back buffer, or rather events. And I do think it's supposed to render it, but I think it's something about my draw calls, maybe. Yeah, let me just fiddle around with my old stuff here. We could, of course, just encode some color as well in the struct, just to be sure. So when we create the color, let me see. Yeah, I think my vertex shader is fine. Or maybe I just inside the vertex shader I want to uh, let's do it like that, and we set the output color to did I, let me see, pixels shader last time. No, I actually used normalized values. Mm. It's a rendering API, meaning that you can use your graphics cards to do graphics. It does have uh, a part of a part of the library actually is able to do bounding boxes, which means that you can do physics. They actually do ship it, but to use it you have to produce some code. So do you know OpenGL, for instance? Yeah, DirectX is like OpenGL and Vulkan. It's more like Vulkan than OpenGL actually, because it's more complicated than OpenGL. But so when you do a game engine yourself, you do the graphics in OpenGL, Vulkan, or DirectX, or perhaps even all three if you can manage, and then you do physics um, by the side. You do simulation code for that, and audio is a whole other topic. So yeah, we're only doing graphics right now. And um, well, you could argue that DirectX doesn't give much benefit over Vulkan, but I do think that the debugging layer is better in DirectX, and therefore it's perhaps less frustrating to work with once you get started. But yeah, if you do want to run on mobile or Linux or whatever, you should definitely run with Vulkan instead. Or if you want to start out, OpenGL should also be usable on most platforms. But yeah, I actually never got to work with Vulkan. I started on DirectX first, and then even though it was tough, I kind of stuck with it, and then yeah, I haven't really gotten into Vulkan since then. But I would think that they are somewhat similar, since it's limited how much difference there can be when the APIs get complex enough. It's just basically a tool for communicating with the graphics card anyway. Well, I did put in some, let's see. So this should in itself should in itself yeah, exactly. Have you tried working with OpenGL or Vulkan? Oh, I can't remember what I'm missing. Let's see. All right. Did you get to render something to the screen, or did you have to forfeit, fight, for give up, whatever it's called? Uh, ah, that sounds nice. I like working on Android, even though I have to do Java since I haven't learned Kotlin yet. I've been messing around with native C++ inside Java with Neon intrinsics. I want to do JNI. Let me see. Yeah, exactly. I wanted to do a machine learning algorithm built in C++ on the Android uh, on an Android device. So far, I haven't gotten to the end result yet, but it's fun. What am I missing here? I know I'll realize it whenever um, I stop working on this. Let's see. Uh, maybe. Let's see. Uh, Yeah. So I don't think we bind any render target. We only clear the render target, but we do not bind one. Mm. Let's see. Let's do a D12 command list manager call to get the graphics command list and set render targets. One descriptor. Our swap chain will give us the current RTV target, or rather the handle. And the last one I'm allowed to leave as null, right? Let's see. Let's try to run it with false. And this will be a null pointer. And we pass it as a reference. Let's see. Requires an L value. God damn it. Okay. Let's do a CPU descriptor handle then. RTV handle, and we store it like that, and then pass in the handle and the address of the handle. Yeah, I know how you feel, man. I started doing C++ about a year ago or something like that, maybe more, maybe 1.5 year on and off. And at the beginning, I was like so frustrated with the compiler and the debugging of it and so forth. But nowadays, I really gotten comfortable with it and do not feel the same feelings of overwhelming confusion. But yeah, let's see. Okay, we do get an error, but at least we're getting close to something. So the render target does not match that specified by the pipeline state. The render target format. Let's see. The first time we got that error, did it tell us anything else? Nope. there's something about the ordering here. So it's set to common or present, and that's what it's telling us is wrong all along. Let's see, am I supposed to transition the resource? I do transition the resource then. Let's see, state before, state after, so it's not swapping the let's see. Yeah, yeah. Void pointers are really tough to wrap your head around. Just imagine that a void pointer is something that can be any type of pointer because it's no kind of pointer. And the return type is all, when it's void, it just means it doesn't return anything. In C++, you can use references as well. So that allows you to kind of not use pointers that much, if that makes sense. For instance, let me just type out a function here. If I do a test function here, we can pass in a pointer to something like an int pointer. Let's do int pointer like that. But if I do the exact same thing, but I do pass in a reference to an int, this is actually also a pointer, but the compiler does a lot of stuff for you, so that if I wanted to change the value of this pointer, I would have to do like that. Then the referenced value variable would be changed, but if it's passed by reference, I can just do like that. And these things will work the same. So let's do the last version here with the void pointer. So this is now a void pointer. So that means that if I know how the memory, let's see, the memory is aligned, I can actually change this into anything as long as the memory which underlies the variable is correct. And I think that is probably the biggest benefit of C++, as well as the biggest task to undertake is just a second. All right, that's fair enough. I mean, like C++ is really, really, really close. Uh, what am I trying to say? I'm trying to say that C++ requires deliberate memory management, and that can be really, 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 really tough to process and especially debug. So I feel ya, but yeah, eventually I got the hang of the pointer stuff, and now it doesn't bother me. But I do remember in the start I was like, what the fuck is a pointer and what is a void pointer and what am I supposed to do with it? Um, but I might be logging off for now, or at least for today. I've been having a real go at it today. I think I perhaps streamed 10 hours or something in total. So yeah, we're really close to getting something on our screen. The pipeline even receives the data, and the shaders should be working. And welcome. Thank you for the follow. Um, Feel free to to ask if you have any questions about the C++ stuff, or yeah, yeah, we will. Have a nice one, man. And thanks for dropping by. See you around, man. Of course. I'd love to.